Hello, this is Mr. Oziak, and today we're continuing looking at our algebra. And in this video, we're going to take a look at solving systems of linear equations. Systems means that we're solving more than one equation where there is more than one unknown variable, and all those unknown variables satisfy all the equations at exactly the same time. So in this case, we have two equations with two unknowns, and when we find a solution to those two equations, the solutions will be true for both of those equations. There are two methods that we can use to solve those equations. There are three actually, but we're going to use two only. So the first method is called method of elimination. And the way it works is that we're going to rearrange this equation so that coefficients of one of the unknown variables are the same. Okay, so I'm going to continue writing that little curly bracket around my equation so that it reminds me that I'm dealing with a system. So I'll rewrite the first equation. 5x minus 3y is equal to 7. And I'm going to move y onto the left-hand side and minus 3 onto the right-hand side. So when I move terms across the equal sign, I do always change the sign, so it will turn into 2x. Y goes here, so it turns into minus y. And minus 3 goes here, so it turns into plus 3. Okay, so now I want to transform those two equations in such a way that the coefficient in front of one of the variables will be the same. So maybe let's change the coefficients of x. Coefficients will be 10 because 5 and 2, the lowest common multiple of 5 and 2 is 10. So that's what I'm going to change. I have to multiply the first equation by 2 and the second equation by 5. So I'm going to choose that, multiply by 2. And multiply by 5. Remember, I multiply every term in the equation. So I'm going to end up with 10x minus 6y is equal to 14. And 2x times 5 is 10x minus y. So that's minus 5y. And 3 by 5 is equal to 15. Okay, so almost there. Take a look at this situation over here. If I wanted to add those two equations, I'd get some result. But if the sign in front of 10 was minus 10, so if that was a negative term, after adding those two equations, the terms with x would cancel. And I want to get to that situation. So I'm going to multiply just this equation over here by minus 1. And when I multiply it across, I'm going to end up with a result that looks as follows. Over here, I have 10x minus 6y equals to 14. And I multiplied all terms by minus 1 over here, so I end up with minus 10x minus 5y times minus 1 is plus 5y. And minus 15 times minus 1 is equal to minus 15. So now I can draw a straight line and add the respective terms. So when I add the constants. 14 minus 15 is equal to minus 1. Minus 6y plus 5y is equal to minus y. And 10x minus 10x is equal to 0. So I don't need to write anything over here. And I get that minus y is equal to minus 1. So I'm going to multiply both sides by minus 1, just to get rid of the minus in front of my unknown, and I get that y is equal to 1. Okay, so now I can use value of y equal to 1 to solve my original equation. So let's take a look at this one. So minus 3 plus 2x is equal to 1, and I move minus 3 on the left onto the right hand side. I get that 2x is equal to 4, divide both sides by 2, and I get that x is equal to 2. And that's my solution. X is equal to 2, y is equal to 1, that's the solution to the system of those equations. The other method that we should be aware of is the method of substitution. How does it work? Let's make y the subject of both of those equations. So in here, we already have the situation that y is equal to 2x minus 3. And if we rearrange this equation, we'll get that minus 3y will be equal to 7 minus 5x. And then that we can rewrite this again. Y is equal to 2x minus 3 and y is equal to 5x minus 7 all over 3. And that's a system of equations. Now if you look at this situation, we have y on the left hand side here and y on the left hand side right over here, so we can equate those two equations and equate the right hand sides, because if the left hand sides are the same, then the right hand sides are the same as well. So if we do that, we're going to get that 2x minus 3 is equal to 5x minus 7, all that over 3. Cool. I want to get rid of that fraction, so I'm going to multiply everything by 3. So 6x minus 9 is equal to 5x minus 7. Move unknowns onto the left hand side and constants onto the right hand side. Move unknowns first. 6x minus 5x is equal to, let's just rewrite it maybe. Let's do it slowly. 6x minus 5x is equal to minus 7. Minus 9 goes to the right hand side, turns into plus 9. So I get that x is equal to 2. And then I can put that x back into my original equation, where I get that y equals to 2 times 2 minus 3. So then x will be equal to 2 and y will be equal to 1. I got the same solution using two of the methods. So that this is the kind of way that we would deal with those equations, and I would like you to let's add another slide. I'd like you to take the following into the account when you're solving those equations. The first thing is to rearrange the equations so that unknowns are on one hand side, let's say left hand side in this case, and constants on the right hand side. You can do it the opposite way, right hand side and left hand side. It doesn't matter, as long as you separate the concerns and the variables and the constants. Then the following step will be to decide if you want to use elimination or substitution. If you want to use elimination, you have to transform equations so that one of the unknowns has the same coefficient, then eliminate it, and then solve. If you want to do the substitution method, what you need to do is make one of the unknown subject of both equations, which means that it will be either x equals to or y equals to. solve that equation and find the second one. And that's it. If you have any questions about solving systems of linear equations, leave me a comment, or you can follow me on Twitter at Mr. Ozjak, and I'll see you next time. Thanks for watching.